So hello and welcome to my channel. So recently I've watched a gameplay video of a new game called LIGHTMATTER, and in that game, we have to keep staying under the light because shadows will kill us. So it's a puzzle game, something like Portal, but in this one it's like you have to move lights and stuff so that we can progress through the level um, as long as there is light on us. Otherwise, we will die because shadows kill us. So let me just show you what I mean.
The puzzles all revolve around moving light sources to eliminate shadows, because the shadows will dissolve and kill you on contact. It's kind of like the floor is lava, but only in the shadows. The variety of puzzles is limited since you only have two different kinds of lights you can use. Lamps that always project a large beam in one direction, and orbs that light up a small area around them when in line of sight with a specific power source you can find throughout several rooms.
So as you can see, we have to keep staying under the light to stay alive, right? So today I'm going to be showing you how the developers have implemented that into the game. So how does the game know that you're in shadow and then you should die, and how does it know that you're under the light and you need to stay alive so that you can progress through the level? So I have a simple scene here in Unity, and it's just it's just a spotlight and then a cube, which I'm naming it the player, and then the ground. So the player has a material. This is just a custom material, and it's just using the diffuse shader that's already inbuilt into Unity. So okay, look, check this out. If I play this and I click on player, look, now the player is under the light, right? When it's under the light, it's green in color. When it's out, it'll be red. This is like the basic mechanics of light matter. So how did I implement this? And this is not just like me putting a collider there or a trigger or whatever. You can see that if I move the spotlight, see how it changes? I don't even have to move it. I can rotate. It would still change. See? So the way that I'm doing this, and this is very simple, by the way. Let me show you the code, and it's pretty nice to play with actually. Look at this. Okay, so let me show you the code. So this is it, and this is a script that is attached to the player. It's called the player script here, and I have a reference to the spotlight object. Now in the game, there can be many spotlights at once, so they must be putting it in a group or something, or putting it as a tag and just checking, doing the same check for all the lights basically. So this is just for one light, just to show you how it works. So we have a reference to the spotlight that I've put in the editor over here, and then yeah, this angle, this spotlight angle, is actually this one. This under light, there's a spot angle. That's the one that I need because I need to calculate the angle at which the player is and check whether it's under the light or not. So that's the angle that I'm using, and then the calculation is really simple as well. Look at this. It's just like, this is it. That's literally it. For one light, and to check if it's under the light or not, this is it. So what I'm doing here is I'm getting a direction from the light towards the player, and that's using this small vector calculation, and then I normalize that so that I just get a direction and no magnitude. And then after that I do a dot product, and I'm doing a dot product because I need to see the angle, right? I need to see the angle between the light's forward vector and the direction towards the player, so that I can see whether the player is inside the light or not. So yeah, so I just do a dot product of the light to the player, the direction of the light to the player, and with the forward direction of the spotlight. And then I'm just doing a check, a simple check, whether it's greater than the cosine of, and this is, I'm using mathf dot degree to radians, because the cosine function in Unity, it takes radians, it doesn't take degrees, so that's why I'm converting it. And so this cos, mathf dot cos, spotlight angle divided by 2. I'm doing divided by 2 because so yeah, I need to divide it by 2 because this is actually like the full angle of the light, and we just need like half of it, because we're gonna check like in a circular manner, because dot product checks in a circular manner. So yeah, so that's why I'm dividing it by 2. And then I'm just checking if the answer, like the dot product answer, is greater than or is equals to that thing, the cosine of that angle, basically. So if you don't know trigonometry, like cosine of 0 is 1, and cosine of 90 is 0, cosine of 180 is minus 1. So basically, I'm trying to say that, okay, I want to see how this the direction of the player is with respect to the light, how close it is to the forward direction of the light. That's it. That's all I'm checking. So if it's greater, that means it's still inside that angle. If it's inside that angle, then I'm just changing the material to green. We can do anything really. This is like we're in the light, and this one is when we're in the shadow. So when we're in the shadow, I'm just changing the color to red, whereas in the game it just kills the player. And then when we're in the light, I just change the color to green, whereas in the game they just let the player stay alive. So yeah, pretty cool result. Well, what is this now? So yeah, it's pretty cool. Look at how it changes. And right when the light stops touching it as well. Pretty cool. Rotate that. Look at that. Pretty cool, right? Right. I'll see you next time. Peace.